Hello my friends and welcome back to the You Can Do TV channel. Coal does not begin as rock but as ancient life. Millions of years ago, dense vegetation settled in swampy landscapes, gradually buried under layers of sediment. Pressure and time transformed this organic matter into coal. Today, at Severochesky Doli in northern Bohemia, that history is revealed on an industrial scale. The journey of coal continues with surface mining, where the Bagger 293 bucket wheel excavator dominates the landscape. This massive machine cuts continuously through overburden and coal seams, extracting material with controlled precision. From excavation to transport and processing, each step follows a carefully engineered sequence, turning geological time into energy for modern industry. Metso's filtration systems form a critical technical backbone of the JSPS pelletizing operation. The plant operates 8 high-capacity industrial filters designed for continuous duty, achieving consistent availability levels around 95%. These units deliver precise moisture control, reducing cake moisture to approximately 9.5%, a key parameter for stable green ball formation and downstream pellet quality. Robust mechanical design, optimized filter media, and efficient hydraulic systems allow reliable 24/7 operation with minimal, unplanned downtime. Maintenance accessibility and rapid troubleshooting, supported by strong R&D and process expertise, ensure long service life. Compared with alternative technologies, Metso filters provide superior cleanliness, stability, and process reliability. Before concrete is poured and asphalt is laid, everything begins with the quality of the sand. At this production site, manufactured sand is engineered, not improvised, through a tightly controlled crushing and shaping process built around advanced SPM technology. The system combines a VSI 5X series sand making machine with an HPC series multi-cylinder hydraulic cone crusher, forming a high-performance circuit designed for consistency, efficiency, and industrial scale output. The process begins with primary and secondary crushed material entering the HPC cone crusher. Its multi-cylinder hydraulic system delivers precise crushing force, stable operation, and automatic overload protection, producing a well-graded intermediate product. Real-time hydraulic adjustment allows the discharge setting to be optimized under load, ensuring uniform particle size and reduced liner wear. This controlled output is critical for downstream sand shaping. Material then flows to the VSI 5X sand making machine, where high-speed rotor technology accelerates stone against anvils and material beds. This impact-driven mechanism refines particle shape, increases cubicity, and removes weak edges, producing sand that meets strict concrete and asphalt standards. The VSI 5X design also incorporates optimized feed distribution, wear-resistant components, and efficient airflow management to maintain stable production. Throughout the site, conveyors, screening units, and dust control systems are synchronized to maintain continuous operation. Automation links crusher performance, sand quality, and throughput into a single production logic, reducing manual intervention and energy consumption. Together, the HPC cone crusher and VSI-5X sand-making machine form a modern manufactured sand solution, capable of delivering high output, superior particle shape, and reliable long-term performance for large-scale aggregate and infrastructure projects. Engineered for high-throughput efficiency, the 700 TPH iron ore wash beneficiation plant in Australia is built around a robust, process-driven layout. The M4500 wash unit performs precise washing and cut sizing at 5/32 inch, preparing material for downstream separation. The lump ore circuit applies jig-based gravity separation, paired with high-capacity dewatering screens to ensure effective moisture control. 17 static and radial conveyors maintain uninterrupted material flow across the site. In the fines circuit, cyclones remove slimes before spiral separators recover valuable fines through density-based separation. Two A1500 systems close the loop with advanced water recycling and sludge management, ensuring operational stability, reduced water consumption, and consistent product quality at scale. In June, a carefully planned blast marked a decisive milestone at the Vama Hydropower plant. AF Group detonated 10 tons of explosives in a single, controlled operation, completing the final blast of the project. The event closed a critical construction phase, reshaping solid rock with precision and engineering discipline. For more than a century, the gyratory crusher has stood at the heart of primary crushing. In its hydraulic form, that legacy evolves into a machine built for scale, stability, and control. Uniform product sizing, reduced liner wear, and production rates up to 4 times higher than jaw crushers define its performance. Hydraulic cone support and energy storage systems absorb overloads and fine-tune the discharge opening with precision. This design simplifies material handling, reduces auxiliary equipment, and makes the hydraulic gyratory crusher the preferred solution for large and medium-scale mining operations processing hard rock. Metso's filtration systems form a critical technical backbone of the JS pelletizing operation. Metso supplies a complete processing chain covering raw material handling, crushing, beneficiation, coal washing, pelletizing, and high-capacity filtration. Filtration units consistently achieve over 95% availability, delivering low residual moisture essential for stable green ball formation. Pellet plants, each rated at 4.5 million tons per year, operate at full load with availability levels exceeding design parameters. Reclaimers run continuously in 24/7 duty cycles, while energy consumption for fuel, oil, and power remains among the lowest in the industry. Product quality benchmarks include CCS values above 270 and tumble indices exceeding 94. At the Tyrios Dobrovice sugar refinery, construction is underway on a unique storage silo designed to hold up to 50,000 tons of sugar. Stakshima supplies specialized construction chemicals for this demanding project, supporting a structure built using Slipform technology. The silo walls require concrete with precisely engineered properties, balancing workability, strength development, and long-term durability under continuous casting conditions. Advanced admixture formulations ensure stable rheology, controlled setting behavior, and consistent surface quality throughout the lift. This technically refined approach enables uninterrupted construction, structural reliability, and the successful realization of a large-scale, high-performance industrial storage facility. High above Bavaria, at the historic Racing Earth station where Apollo once communicated with Earth, a new chapter unfolds. The massive ray dome, shaped like an enormous air-supported sphere, protects the satellite dish beneath it. After a violent storm destroyed the original envelope, a replacement must be installed with absolute precision. At the center of the operation stands the Liebherr 1650. The lift demands technical discipline. A 10-ton membrane hoisted nearly 50 meters, drawn upward at a strictly calculated maximum of 1.5 meters per second. Even minor wind loads exceed tolerances, forcing delays. Thermal conditions add further constraints, pushing both crew and equipment to operational limits. The crane configuration reflects the scale of the challenge. Equipped with 155 tons of hydraulically adjustable ballast, a 56-meter luffing jib, and an extended telescopic boom reaching nearly 100 meters in hook height, the Liebherr 1650 clears the vast satellite dish with engineered confidence. From bridge installations to complex steel structures, the crew has executed demanding lifts before. Yet this installation, suspended on the edge of space, stands as a defining highlight. In the heart of Manchester, where space is tight and logistics leave no margin for error, Cable Street rises as a carefully engineered response to an unforgiving urban site. Designed as a 9-story AC Marriott hotel, the project demands speed, precision, and absolute control over construction sequencing. This is where F.P. McCann's precast expertise becomes central to the story. Working alongside main contractor Bardsley, F.P. McCann delivers a complete precast concrete frame tailored to a site with minimal offloading capability and virtually zero storage capacity. Just-in-time delivery is not a preference here. It is a requirement. The solution includes around 250 solid floor slabs, nearly 300 structural cross walls, and 251 brick-face sandwich cladding panels, all manufactured off-site under controlled factory conditions. Precast stair flights, landings, stair cores, and lift cores are fully integrated, enabling rapid and predictable vertical construction. Each element begins with detailed design coordination between engineers, production teams, and quality control specialists. Reinforcement cages are fabricated using automated systems, while formwork and casting components are assembled with millimetric accuracy. The brick-faced panels present a particular challenge. Irregular handmade bricks are individually placed by trained operatives using alignment strips to achieve consistent geometry before casting. Concrete is produced in-house using high-capacity pan mixers, supported by continuous laboratory testing to ensure performance and repeatability. Once cured, units are inspected, finished, and prepared for transport. F.P. McCann's dedicated logistics fleet allows direct factory-to-site delivery, eliminating double handling and reducing risk. From early design input to final installation, Cable Street demonstrates how a fully managed precast strategy transforms severe site constraints into a controlled, high-performance construction process. Full-width chip seal is a surface treatment designed to extend pavement life while restoring skid resistance across the entire roadway. The process involves spraying a uniform layer of binder, followed by evenly graded aggregate, creating a durable, textured wearing course. Applied edge to edge, it seals existing cracks, protects the underlying structure from water intrusion, and improves traction in both dry and wet conditions. Full-width chip seal is particularly effective on low to medium traffic roads, delivering fast installation, minimal disruption, and a cost-efficient alternative to traditional resurfacing while maintaining consistent surface performance. Spotflex is a cold plastic road marking system engineered for high-traffic environments, produced by Metalback and Farb using structured Farboplast technology. Its symmetrical three-dimensional profile classifies it as a Type 2 road marking, delivering long-term visibility at night and in wet conditions. The material offers excellent substrate adhesion and high durability, reduces aquaplaning risk, resists snowplow damage, and provides audible feedback when crossed, enhancing both safety and driver awareness. In the Northeast, Willow Tree operates a high-efficiency power screen crushing train engineered to process limestone with precision and consistency. Supplied by Blue Group, the system begins with a PT400 jaw crusher, delivering reliable primary reduction from blasted rock. Material is then screened by a Warrior 1800 to control feed sizing, before entering the 1000 MaxTrack cone crusher for secondary and tertiary shaping. Final classification is handled by 3 Chieftain 2100X screeners, producing tightly graded end products to specification. Designed for continuous operation, the crushing train combines robust throughput, controlled material flow, and flexible screening capacity, supporting Willow Tree's demand for high-quality limestone across multiple construction and aggregate applications. On steep stream banks, erosion control must work with nature, not against it. Fleximat provides a low-profile, eco-friendly armor that stabilizes slopes while allowing riparian vegetation to take root. Willow stakes and native plantings grow through the mat, protecting banks, maintaining natural flow, and resisting debris buildup. For centuries, houses were built brick by brick. With the BOD, that logic was rewritten. This project delivered Europe's first 3D printed house, formed layer by layer by a robotic printer instead of human hands. Digital design guided every movement, cutting waste, accelerating construction, and turning a bold experiment into a livable reality, signaling a new chapter in how homes can be built. In Nidzika, a new precast concrete arch bridge has been delivered using the advanced Optim system, demonstrating how modular engineering accelerates modern infrastructure. The structure was manufactured from high-precision precast elements produced in controlled factory conditions, then transported and assembled directly on site for maximum efficiency. The project included the installation of precast arch segments and structural supports, utilizing approximately 220 cubic meters of concrete and 365 tons of reinforcing steel. The completed bridge spans 98 meters with an overall width of 43 meters, forming a robust and geometrically optimized load-bearing system. Modular assembly significantly reduced on-site construction time and minimize disruption to surrounding traffic corridors. Compared to conventional cast-in-place solutions, the Optim system delivers faster execution, enhanced durability, and lower long-term maintenance requirements. Its structural efficiency makes it ideal for roadways, railway crossings, and wildlife passages. The result is a resilient, long-span structure designed for long-term safety, performance, and streamlined project delivery. Over Easter weekend 2018, a tightly choreographed engineering operation unfolded on Ireland's busiest rail corridor. At Osborstown near Sallins, a new underbridge was installed beneath the main Dublin-Cork railway line, enabling a critical road bypass for Kildare County Council. The challenge was uncompromising: deliver a permanent structure under an active rail line within a single holiday possession. Success was built months in advance. Contractors constructed the underbridge in multiple reinforced concrete sections beside the live railway. These elements were cast, cured, and inspected offline, while foundations, abutment interfaces, and temporary works were prepared with millimetric accuracy. Detailed construction sequencing, lifting plans, and contingency scenarios were finalized long before the railway closure began. At 0:30 on Good Friday, the rail possession commenced. Track, ballast, and subgrade were removed in rapid succession, exposing the embankment for excavation. Working continuously, crews cut through the formation, installed temporary support systems, and prepared the bearing levels. Precast bridge sections were then transported into position, lowered, and assembled to form the complete underbridge structure. Structural connections, waterproofing, and drainage were completed immediately to protect long-term performance. Once the structure was secured, backfilling proceeded in controlled layers, followed by reinstatement of the rail formation. Ballast was placed, track relayed, and alignment precisely adjusted before final tamping and testing. By 10 o'clock on Easter Monday, the railway was fully reinstated, and passenger services safely resumed at 12:30. The operation demonstrated how off-site construction, disciplined planning, and continuous execution can compress complex civil engineering into a single weekend, delivering vital road infrastructure while keeping national rail disruption to an absolute minimum. A live structural test marks a milestone in foundation engineering. One of the world's first 3D-printed pad foundations is being evaluated under real load conditions. The system replaces conventional substation foundations while reducing material use by 75%. The printed concrete element, integrated with Payco's steel anchor bolts, is tested under horizontal and vertical pull forces to verify structural performance. Results confirm that just 25% of traditional material volume can achieve required strength, significantly lowering cost, construction time, and long-term carbon dioxide impact. Precision meets ground engineering, as the Kemrock KSI 12000 installs a diaphragm wall using a soil cement mixture. The cutter mixer blends in-situ material with binder, forming a continuous, low-permeability barrier. This method delivers structural stability, groundwater control, and efficient execution in confined urban construction environments. At Canal Bellavista in Chile, concrete canvas was deployed to deliver a fast, durable channel lining solution. Works commenced in June 2017 with drainage pipe installation to manage subsurface water and ensure long-term stability. The canal was then reprofiled to achieve the required geometry and flow capacity. Concrete canvas was carefully unrolled along the prepared surface, with overlaps mechanically fastened to secure continuity. The lining was staked firmly into position to prevent movement during hydration. Finally, controlled hydration activated the cement within the fabric, forming a hardened, erosion-resistant concrete layer that protects the canal efficiently and reliably. Along a canal in Bromsgrove, a 14-meter towpath retaining wall was reconstructed using Slipform concrete bagwork technology. Rising 2 meters high, the structure combined 8 pallets of 32N underwater pre-filled bagwork and 33 pallets of 32N above water units. Each Hessian bag contains a ready-to-use dry concrete mix with biodegradable or soluble liners, allowing controlled placement and reliable curing. The system enabled efficient installation, structural stability, and minimal disruption to the surrounding waterway environment. Precision begins long before the first wall rises. Red Block, the prefabricated clay brick element system from Schlagman Poriton, is engineered for single-family homes, multi-story residential buildings, and commercial projects alike. Each element is factory-produced to project specifications, delivered ready for rapid assembly. On-site, the floor slab is carefully set out, with all wall lines snapped and marked according to the installation plan. Critical references, wall alignments, offsets, and numbering ensure flawless positioning. A mineral sealing slurry or bituminous membrane forms the horizontal damp-proof course. Leveling shims and surveying instruments guarantee exact elevation control. A fresh mortar bed is prepared for every element. The first red block panel, pre-fitted with an integrated damp-proof layer, is craned into place, aligned vertically with adjustable braces, and secured. Montage foam is applied at vertical joints to create airtight, thermally efficient connections. Corner details are precisely marked and bonded. Integrated lintels are factory pre-installed when specified, while shutter boxes are fitted on site. Joint gaps exceeding tolerance are sealed with mortar. The result is a structurally sound, dimensionally accurate masonry shell, assembled with speed, cleanliness, and engineered reliability. Concrete production at Zappa follows a precisely controlled technological process designed to ensure consistent quality, strength, and performance. The primary components include graded aggregates, cement, water, and selected admixtures that enhance workability, durability, and setting characteristics. Each raw material is stored separately and proportioned automatically according to a predefined mix design. Aggregates are first weighed and conveyed into a high-capacity mixer, followed by cement, water, and chemical additives. An advanced control system monitors batching accuracy, moisture content, and mixing time to guarantee a homogeneous concrete mix that meets specified structural and durability requirements. Once mixed, the fresh concrete is discharged into transit mixers and delivered directly to the construction site. Timely transportation and placement ensure optimal performance, preserving the designed mechanical properties and long-term reliability of the concrete structure. Beneath the surface of ordinary asphalt lies the potential for architectural transformation. Decorative paving solutions convert standard pavement into realistic cobblestone, brick, or slate finishes without sacrificing structural strength. The system integrates the flexibility of asphalt with advanced epoxy-modified acrylic coating. The process begins with precise surface preparation, including measurement and pattern layout. The asphalt is heated using a reciprocating propane heater to achieve the optimal imprinting temperature. A specially woven steel template is then aligned and compacted into the softened surface, forming a detailed and consistent pattern. Edges are refined manually to ensure definition and continuity. Once imprinting is complete, the area is masked and coated with a water-based, environmentally responsible polymer blend. Multiple spray applications enhance coverage, UV resistance, and long-term performance. The finished surface withstands traffic and weather exposure while retaining vibrant color and structural integrity. In Frankfurt, a new multi-story residential building is taking shape with remarkable speed. Designed to deliver around 400 square meters of living space, the structural shell is completed in just 5 days using a solid timber modular construction system. The micro-modular approach transforms site logistics. Elements are stacked cleanly, assembled dry without mortar, and installed with exceptional precision. Individual timber bricks interlock to form load-bearing walls, reducing errors, waste, and construction time. Beyond speed and cost efficiency, the system answers a larger challenge: resource conservation. Built entirely from renewable timber, the modules can be dismantled, reused, and reconfigured, turning housing construction into a genuinely circular process while locking in long-term carbon storage. At the HS2 trial site, concrete canvas was evaluated as a high-performance alternative to traditional in-situ concrete channel lining. The installation demonstrated multiple deployment techniques, including 3-wide longitudinal placement for continuous runs, corner transverse deployment to accommodate directional changes, and straight 3-wide transverse installation for wider sections. Once positioned, the material was securely fixed and fully hydrated, activating the cementitious layer. Following curing, controlled backfilling completed the system. Engineered for rapid construction, concrete canvas can be installed at rates of up to 2,000 square meters per day, with deployment speeds exceeding 400 square meters per hour. The material offers uniform thickness, reliable surface integrity, and effective weed suppression, reducing long-term maintenance requirements. Installation is achievable in varied weather conditions, minimizing program delays and lowering overall project costs. Environmental performance is a defining advantage, delivering approximately 55% reduction in embodied carbon compared to conventional concrete lining. Fewer vehicle movements and reduced channel preparation further decrease site impact. Manufactured in the UK and designed for a 120-year service life, the system provides a durable, low-carbon solution aligned with modern infrastructure standards. High above the Allgäu region, the winding access road to Falkenstein Castle ruins demands precision engineering rather than routine paving. This narrow mountain lifeline must remain open for deliveries, staff, and visitors, making pavement rehabilitation both a logistical and operational priority. The project features extreme gradients exceeding 30% and multiple tight hairpin bends, restricting access to three-axle trucks. Asphalt transport and maneuvering heavy equipment along the steep confined alignment require careful coordination and experienced operators. At the center of the operation is the Vogel Super 1800 paver. Despite its size, the machine maintains excellent tracking stability through sharp curves and steep inclines. Enhanced visibility from the operator's platform improves site safety, while advanced control systems ensure consistent paving quality. Variable layer thickness compensates for aged pavement and asphalt slippage, supported by effective pre-compaction from the pressure bar. Compaction is completed using HAM HD10 and HD13 rollers, where operator expertise is critical on the demanding terrain. Tunnel fires escalate rapidly, driven by confined geometry, high thermal loads, and restricted evacuation routes. Early detection and immediate suppression are decisive. The stationary 1/7 CAF system intervenes within critical minutes, delivering high-performance compressed air foam before fire brigade arrival. The system generates highly adhesive foam that clings to walls and ceilings, protecting structural linings while suppressing flames across diverse fuel types and flammable liquids. Activation is controlled centrally or locally, ensuring operational flexibility. Engineered for various tunnel lengths and cross-sections, the dry pipe configuration with remotely actuated valves minimizes maintenance. Integration with 1/7 hose lines enhances defensive firefighting capability and supports extended tunnel use, including heavy and hazardous transport corridors. A Zeitraffer revealing Germany's first 3D printed home captures a groundbreaking moment in modern construction. In Beckum, North Rhine-Westphalia, a two-story single-family house was printed on-site with a robotic concrete printer installed by Perry, using specially formulated I.Tech 3D printing mortar. The walls were built layer by layer in about 100 printing hours, creating a 160 square meters home that showcases faster, more sustainable methods than traditional construction. Architectural character often emerges in the details, and few details elevate a facade like a line of precisely cast concrete balusters. Using cast-in-situ plastic baluster molds, decorative railings can be formed directly on-site with accuracy and repeatability. The procedure begins with careful surface preparation. The base is smoothed to ensure clean demolding. Then a release oil is evenly sprayed inside each mold to prevent adhesion. Plastic molds are positioned accurately along the railing line and firmly clamped to the base to maintain alignment during casting. Concrete is mixed to the specified consistency and poured steadily into each mold cavity. A through-hole is drilled to accommodate a steel support bar, which is inserted to reinforce structural integrity. The remaining space is filled and compacted to eliminate voids. After curing, the molds are dismantled, revealing sharply defined baluster profiles. Finishing includes exterior-grade paint application using spray equipment. From classic marble tones to custom colors, the final coating enhances durability, while delivering the desired architectural expression. The FiberNet Intonaco Armado system refers to a reinforced plaster technique used to strengthen and consolidate masonry structures. This approach, known as composite reinforced mortar, integrates pre-formed composite meshes and connectors with structural mortars to create a reinforced layer that enhances shear, flexural, and compressive capacity of walls and structural elements. Once in place, structural mortar is applied over the mesh in a single layer, embedding the reinforcement and creating a continuous, high-performance coating. Concrete slabs rely entirely on the soil beneath them, and that soil is constantly changing. Settlement, erosion, poor compaction, and moisture variation can cause slabs to sink or tilt, creating safety hazards, structural stress, and costly damage. When repair is required, full replacement is disruptive and expensive, while traditional mudjacking uses heavy grout and large drill holes. A modern solution is slab lifting with AP Lift 430 polyurethane foam. Small 3/8-inch ports are drilled and high-density foam is injected beneath the slab. As it expands, it fills voids, stabilizes the subgrade, and precisely lifts the concrete. Most repairs finish in hours, with service restored in about 45 minutes. Thermocolor P26 is a high-performance thermoplastic material engineered for durable flat road markings. Applied at a thickness of 2 to 3 millimeters on asphalt or concrete surfaces, it is heated to 180 to 200 degrees C and installed using extruder or drawbox road marking machines. The material is suitable for longitudinal lines, pedestrian crossings, bicycle lanes, parking areas, and other horizontal traffic symbols. Solvent-free and environmentally responsible, Thermocolor P26 delivers excellent daytime brightness and strong nighttime retroreflectivity, significantly enhancing roadway visibility and traffic safety. Fresh lines redefine a surface long before anyone notices the machine behind them. Easy line striping operates at ground level, where precision matters most. As the unit advances, a controlled spray system lays down clean, uniform markings across asphalt or concrete, restoring order to parking bays, warehouse aisles, and traffic lanes. The mechanism balances steady paint flow with accurate alignment, allowing curves, intersections, and straight runs to emerge with consistent definition. Compact in form yet deliberate in function, the equipment transforms worn pavement into a clearly structured space. What appears simple from above is, in practice, a measured sequence of motion, control, and material performance working in quiet coordination. A clean surface is the foundation of every durable marking system. The pavement is carefully swept to remove dust and debris, ensuring strong adhesion. Edges are defined with tape, and straight lines are established using a chalk line for precise alignment. Plasti-Root Roll Grip is a two-component cold plastic formulated with anti-skid aggregates to deliver high surface friction. The accelerator is added directly to the base material and mixed thoroughly, activating the curing process. Once prepared, the material is poured onto the surface and evenly distributed with a roller to achieve a uniform layer. The masking tape is removed while the coating remains wet, preserving sharp, clean edges. Pre-marked, preformed thermoplastic markings are then positioned on top. The flexible rolls are cut to fit and gently heated, allowing them to bond securely without affecting the cold plastic beneath. The completed system provides durable, high-visibility markings with enhanced safety performance. The Holzleim Massivdecker represents a decisive step away from conventional reinforced concrete. This hybrid floor system combines renewable timber with recyclable clay, uniting the ecological advantages of timber construction with the performance characteristics of a solid slab. High acoustic insulation, enhanced fire resistance, and substantial thermal mass are achieved within a single structural element. The system relies on a castable clay mixture derived partly from recycled filter cake, enabling fast, seamless industrial production with low material and labor input. Manufactured entirely off-site, the elements arrive ready for installation, concentrating complexity in the factory while delivering a circular, efficient, and environmentally responsible structural solution. Bathroom waterproofing is a critical protective layer that prevents moisture penetration and long-term structural damage. The process begins with thorough substrate preparation and priming. Penetration coating is applied to stabilize the surface, reduce absorbency, and improve adhesion of subsequent layers. The dry mortar mixture is then mechanically blended with clean water to achieve a uniform, workable consistency. Particular attention is given to exposed and high-risk areas, corners, wall-to-floor joints, pipe penetrations, and drains, where sealing tapes or reinforcing elements are embedded to ensure continuity. The first waterproofing layer is applied to vertical surfaces, forming a continuous membrane. Next, the first coat is spread across the floor area, followed by a second floor layer to increase thickness and reliability in wet zones. After proper curing, the final surface finish, typically tile adhesive and ceramic tiles, is installed, completing a durable, watertight bathroom system engineered for long-term performance. between 3rd and 11th Streets is being reconstructed using precast concrete pavement panels, the first application of this method in Indiana. The system reduces pavement depth and avoids conflicts with underground utilities. Removable, replaceable panels accelerate construction, simplify future utility access, minimize maintenance disruptions, and extend overall pavement service life. Steel rails stretch toward the horizon, but renewal begins long before the first sleeper is lifted. The P95 Matisa track renewal train advances along the existing alignment, like a mobile production plant, transforming worn infrastructure into a fully rebuilt track while preserving the original geometry. Often described as a factory on wheels, this integrated system performs each operation in a continuous, synchronized sequence. Frequently described as a factory on rails, the system advances along the line scheduled for replacement and leaves behind a fully renewed track structure that respects the original alignment, gauge, and longitudinal geometry. The process begins with the fastening removal unit. Clips, anchors, and associated components are disengaged methodically to free the rails without disturbing the underlying formation. The old rail removal module then lifts and guides the rails away from the track axis, transferring them to dedicated handling wagons. A fastening pickup unit follows, collecting residual hardware to maintain a clean and controlled workspace. At the core of the consist lies the primary working group. Here, worn sleepers are extracted in sequence. Hydraulic gripping and lifting mechanisms ensure stable handling while maintaining track geometry control. Once removed, ballast leveling equipment reprofiles the ballast bed. This stage is critical. It restores the design crossfall and longitudinal profile, ensuring uniform load transfer and preparing a stable platform for the new track components. New sleepers are then laid with precise spacing and alignment. Automated placement systems maintain consistent center-to-center distances, preserving gauge accuracy. Immediately afterward, rail insertion units position new rails directly onto the sleepers. The geometry is continuously monitored, allowing corrections in real time as the train advances. Fast clip insertion systems secure the rails to the sleepers with calibrated clamping force. Automated modules such as PMP1, PMP2, and P2R coordinate material logistics, distributing components efficiently and preventing workflow interruptions. Where localized intervention is required, a cutout function enables selective replacement of defined sections without affecting adjacent track. Throughout the operation, integrated measurement and control systems supervise alignment, cant, and gauge. This ensures that the renewed track retains its initial geometric parameters, minimizing the need for extensive corrective tamping after installation. The continuous workflow significantly reduces track possession time compared to conventional renewal methods that separate removal and installation phases. The P95 Matisa configuration demonstrates how mechanized railway engineering achieves high output with controlled precision. By integrating dismantling, ballast preparation, sleeper installation, rail positioning, and fastening into one coordinated pass, the system delivers structural reliability and operational efficiency. The outcome is a renewed track structure ready for stabilization and return to service within tightly managed timeframes, an essential capability for modern rail networks.